day is centred around big data, issues relating to big data and how we work with them as researchers.
My knowledge is in engineering and naval architecture, and I'm here to learn about what big data and so on can do. So I'm here with one mission in mind, to suggest to you that the oceans are very important and to request you to give some thought to bring your talents and your knowledge to helping us better understand the oceans in order that humankind benefits from it.
We believe that the data will be the fourth industrial revolution, because everything will be embedded with sensors. The clothes you wear, the car you drive, the appliance at home, or everything on the street. And this is what we call the fourth industrial revolution, which is a cyber physical system. And the output of this is data.
What we want to do with the day is explore a number of themes: the methodology and innovation in working with big data. We want to explore issues of curation and how we keep these data in the longer term.
So our main challenge, if you think about the V's of big data, really is variety. And that variety is, if you like, a physical variety, so position. Are we measuring position in 1 dimension, 2 dimensions, 3 dimensions with scans? Location, which is a different thing. Where is that sensor? The temperature, the humidity. We might be measuring acceleration to monitor movements. We might be storing images to either calculate differential movement or to look for changes in a structure or for any number of things. But it's not just about the physical variety of what we're measuring, it's also about the time variety.
One of the key parts of the day is to look at issues relating to big data, both from a disciplinary and an interdisciplinary perspective, to bring that together, working particularly with early career researchers, together with leaders of international research centres, and share that expertise.
We have to introduce astronomers to a totally new way of thinking about their data. It's not really their data, it's their right to have time on the machine analysing the data, and then that's it. We want to be able to use the data in many different ways.
For our observation, we went at sea for 6 weeks on the Knorr research vessel here. It's an American vessel. In the North Atlantic here, you can see part of Greenland here and part of Canada here. We had a total running time of over 200 hours within a wind speed range between 4 and 30 meters per second. We measured many parameters with many instruments, so it's a challenge to incorporate all these measurements and to make physical sense of them.
Making sense out of this data is not trivial. So pretty much pharmaceutical companies will tell you that with every new technology that comes on the market that generates a lot of data, they need about 5 to 10 years to understand what that data really means to them.
Life sciences data have very little structure. They grow very quickly, but compared with the sort of data that are coming out of the square kilometre array, they're not that big, but they are getting larger very rapidly, and they have very high heterogeneity. Many, many different data types coming from many different instrumentation types, and the types and the technologies are very unstable. They're changing on a very rapid basis.
One of the things that we really want as an outcome of the day is sharing of ideas and best practice, and also come up with innovative solutions and potentially just make connections for future research potential.